Welcome back, everyone. Today we'll do part C of our lesson 7. We'll be going over solving inequalities. So first of all, what's an inequality? Well, we all are familiar now with equations like these, right? So let's say we have 3a plus b, 3a plus b equals c squared. Okay, so you have one expression which is set equal to another expression. Now with an inequality, this equal sign is replaced by these type of signs. So this one, or this one with a bar underneath, or this one with a bar underneath. Okay, so what are these signs? Well, these signs are greater than, less than sign. So greater than or less than. Okay, and when you have a bar underneath the sign, it means the value can also equal something. So let's look at some examples. Let's say we have y with this sign 7. So the way to read this is that y is greater than 7. So y can be any number or anything that's greater than 7. Okay? So y can be 7.1, y can be 8, y can be 9, y can be 10, and so on and so forth. Let's look at an example. How about we have y with this sign, and let's say still we have 7. So this is whereas y is less than 7. So here y can be any number less than 7. So let's say y can be 6, it can be 5, it can be 4. So any number less than 7 is included. But do mind that 7 is not included, though numbers very close to 7 like 6.9 is included. Okay, now what if I put this bar underneath the sign? So here this is read as y less than or equal to 7. So less than or equal. Okay, in this case y can be 7 also. Okay, so y can be 7, 6, 5, 4, and so on. Also, just to remind you, I'm not writing the decimal numbers here, but those are also included. So anything between 6 and 7 would also be, could also be a value for y. Okay, so in other words, this does not limit it to integers. All right, let's look at an example problem on how GRE might test you on it. So let's say we have this problem here. 1 second. Okay, here's our problem. 2/3 is greater than negative 4y negative 25 over 3. Okay, and the instructions are simply solve for x. Okay, so this is not like a typical GRE problem, since I'm just solving for x here, just to show you how to go about that. Well, actually, since I have a y here, I should write I'm solving for y. Okay, so first of all, I have a fraction here, and fractions are ugly. We like to get rid of fractions. So how about I multiply by 3 on both sides? Okay, again, just like in equations, as long as you do the same thing to both sides, you can do that. So here I'm multiplying both sides by 3. So you'll see 3 and 3 on the left side will cancel. I'll be left with a 2 greater than. Then on the right side, I have 3 times negative 4y. That will give me negative 12y. Then I have 3 times negative 25 over 3. Well, this 3 on the outside and this 3 will cancel, and the fraction goes away, and I'll be left with 25. Okay, simple enough. Well, let's now try to solve for y. I want to have y on one side. So how would I take this negative 25 to the other side? Again, the 25 is negative here. On the left side will become positive, so I'll have 2 plus 25 is greater than negative 12 over y. Okay, so 2 plus 25 is 27, and I have negative 12 over y. Okay, now I want to get rid of this negative 12. So, well, just like we do in equations, we divide by negative 12. I divide both sides by negative 12. But now I have to be careful. With inequalities, what happens is that when you divide or multiply by a negative number, so again, divide or multiply by a negative number, you have to be very careful because the inequality flips. So here I have the sign opening like this. When I divide by a negative number, the sign goes in the opposite direction. Okay, so you have to be very careful about that, but only with negative numbers being divided or multiplied. Over here we actually were multiplying, but we multiplied by a positive number, so we didn't have to change the inequality sign. Okay, so here now the negative 12 and negative 12 cancels, and I get that y is 27 over 12 with a negative sign. Okay, and if I simplify this a bit, I can go 3 times 4 and 3 times 9. So I have negative 9 over 4, which is about 2.25, which is 2.25 exactly. Okay, so this is my solution for the equation. Y is greater than negative 2.25. So I'm reading it in this direction now, which you can do that too. You can say y is greater than negative 2.25, or you can say negative 2.25 is less than y. I also want to show you how this can be represented on a number line. So let's say this is our number line. Here's our 0. I have negative 1 here, negative 2 here, negative 3 here. Negative 2.25 would be somewhere over here, right? I'm gonna circle it, and this equation tells me that y is anything that's bigger than negative 2.25, anything bigger than negative 2.25, but it's not 2.25, so that's why I have a circle here, but it's anything, basically all this on the number line are fair values for y, and it will go to what we call positive infinity. Anyways, this was just to show you how this equation can be represented on a number line. All right, let's do a problem now, an actual GRE problem on inequalities, which actually doesn't deal directly with solving inequalities, but it's still an inequality problem. So here we have negative 12 is less than x and less than negative 2. So let me write it down here. We have negative 12, which is less than x, and x is less than negative 2. So this can also be read as basically x is sandwiched between negative 12 and negative 2 on the number line. Okay, and then the other equation is that 3 is less than y and y is less than 6. So y is between 3 and 6. In both cases, you don't have equal signs, so x and y cannot take the values that are shown here. Which of the following could equal xy? So you're looking at possible values for xy, and the directions here indicate all possible values. So anything over here that might be a possible xy value, you have to pick that. One thing to note is that nowhere here it says that x and y have to be integers, so they can be decimal values here too. So I want to find x and y values that are possible. How about I try finding what's the minimum value of xy possible and what's the maximum value possible. So then I know anything that falls between this range, and which is an answer choice here, must be one of the correct answer choices. Alright, so let's look at what's the minimum possible. So for x, the minimum is negative 12, alright, and for y, the minimum is 3. So if I multiply these two, negative 12 and 3, would that give me the minimum value? Actually, no, because the negative makes things interesting. Actually, negative 12 times 6, which is negative 12 times 6, which is 72, negative 72, oops, let me write that again, negative 72, that's the minimum value, because negative makes things interesting, right? So if you have this negative number for x as the minimum value, you pick the biggest number for y, and that gives you the minimum xy value possible. All right, so that's one bound that I have. What about the maximum? So for maximum, well, how about But first of all, the maximum would also be negative. So how about I take -2 here, which is the maximum that x could be, and 3 here for y. So what would that give me? -2 times 3 would give me -6. And I'm saying this is the maximum. Is that correct? Do you think can there be anything bigger than -6? We know that the maximum has to be negative because x is always negative. If I had picked -2 times 6, I would have gotten -12, which would have been less than -6. So this seems to be the maximum value for xy. So xy is between -6 and -72. All right, so anything that's outside this range can be taken out. So -1.5, 0, 1.5. What about -6? Can x be -6? So I think yes, actually x cannot be -6 either, because you have just a less than sign here. It's not less than or equal. Okay, so x cannot be -6. So your correct answer choices here are A, B, and C. Right. So this is one of the harder problems that you will see on the GRE. Definitely a question which will get you 160 plus. And questions where you have to get all possible values, as you saw over here, they take a lot of time. Okay, definitely put in 2 minutes, schedule 2 minutes for it.